very good evening to Doctor. We want to present assignment Solid Mechanic BMKT 2323, and I want to introduce my team members, including me. My name is Lutresh Analaki Arya, and Pravin Babu Analaki Sivan, Nurarfa Alia binti Helmi, Nick Nelly Patricia binti Nick Azihan, and Dainia Farisha binti Mustafa Kamal. And I want to present about the introduction. The primary objective of this study is to bridge the gap between theoretical mechanics and practical engineering application by evaluating the mechanical integrity of a real-world structure under operational loads. By selecting an actual physical system such as a portable desktop, the study translates physics observation into a rigorous mathematical model, understand and how it handles to various mechanical loadings. Central to its analysis is the development of an idealist model and a complete free body diagram (FBD), which serve as the foundation for identifying all acting external loading, including dead loads, life loads, and environmental forces, as well as internal forces and moments. By applying the equations of the equilibrium EOE, the internal mechanical responses are quantified to determine the structural stability and overall safety. Ultimately, this assessment leads to the prediction of the factor of safety, providing a sound evidence of base justification for the design's reliability and ensuring it meets necessary standards for its intended application through site investigation and structural assessment. This report demonstrates professional standards in engineering documentation and structural modeling. And the objective is, number one, to perform a structural analysis of a real-world structure, to develop idealized engineering models and free body diagrams (FBD), to evaluate mechanical safety and structural integrity.
Good afternoon. My name is Pravin Babu Anak Lelaki Siwan. My metric number is B14240102661. This slide shows the original structure and its engineering prototype. On the left side is the original structure, which is a full scale of the table designed for real-world use. It is conceived for a flat tabletop supported by 4 metal legs. From an engineering prospect, this structure is designed to provide stability, load-bearing capability, and durability. Under the working condition, this material and geometry are selected to safety support apply load such as book, laptops, and human interaction. On the right is the prototype, which is scaled down and simplified engineering model. The prototype is built using lightweight material such as cardboard and wood. It proposed the structure concept, including load distribution, leg positioning, and overall stability and before the final manufacturing. By using the prototype, engineers can identify potential design issues such as weak joints, uneven load transfer, or instability. It also allowed design modification to be made at a low cost and low risk. In conclusion, the prototype acts as validation tools, while the original structure represents the final engineered product. Prototype is an important step in engineering design and to ensure safety, efficiency, and functionality before the mass production. Thank you. This diagram shows the free body diagram of the table. The table has a length of 0.6 meters and is supported by 2 whole steel legs. A downward load of 60 Newton acts at the center of the tabletop. In addition to this, the table itself has a weight of 20 Newton acting downward and its center of the gravity. Each leg also its own weight calculated by base, material and dimension, which is act vertically downward. The leg provide upward reactions forward from the ground that balance all these downward force. Since the load is applied systematically, the reaction force at both legs are equal. The table assumed to be the static equilibrium, meaning the sum of the vertical force is zero. The free body diagram helps us to understand how the load is distributed and ensure the table remaining stable.
My name is Nidnali Berisha Bentini Azihan. My matrix number is B1424100265. Next, I will present the literature view, which discusses the key theoretical concepts that support the force and factor of safety analysis conducted in this study. Point number 1 is principles of static equilibrium. Firstly, the principle of static equilibrium is a fundamental requirement for any engineering structure to remain stable. A structure is said to be in static equilibrium when the vector sum of all forces and moments acting on it is equal to zero. This condition is governed by the equations of equilibrium, where the summation of forces in the horizontal direction, the summation of forces in the vertical direction, and the summation of moments about any point must all equal to zero. In practical engineering applications, these equations are used to determine unknown support reactions based on known applied loads and to ensure that the structure does not undergo translation or rotation. Point number 2, structural idealization and modeling, and free body diagrams. Secondly, real-world structures are often complex, which makes direct analysis difficult. Therefore, structural idealization and modeling are used to simplify the structure into an idealized engineering system. This process involves discretizing the structure into individual members such as beams, columns, and joints. Boundary conditions are also defined by simplifying physical supports into idealized forms such as pin, roller, or fixed supports. In addition, assumptions such as linear elastic behavior and small deformation theory are applied to allow accurate and manageable mathematical analysis. Point number 3, loading types and mechanical response. Thirdly, structures are subjected to various types of loading that influence their mechanical behavior. These loads can be categorized into external and internal loadings. External loadings include dead loads, which are permanent loads due to the structure's own weight, live loads, which are variable loads such as equipment or users, and environmental loads such as wind or vibration. These internal loadings include normal forces, shear forces, and bending moments. The relationship between external loads and internal mechanical response is analyzed using free body diagrams and solved through the equations of equilibrium. Point number 4, factor of safety in engineering designs. The factor of safety is a critical parameter used in engineering designs to ensure structural reliability and safety. The factor of safety is defined as the ratio between the failure load and material strength and the allowable or applied load. External loadings are derived from external sources which apply directly to the structure. As an example, dead loads. Dead loads are permanent loads as a result of the structural components' own weight, such as beams, columns, slabs, and connections. Live loads, variable and moving loads such as occupants, equipment, furniture, temporary storage, whereas dead loads are stable in magnitude and position. Live loads vary in magnitude and positions. Lastly, environmental loads. This includes wind loads, vibration, and other dynamic effects which may act intermittently on the structure, not necessarily dominant, but they can substantially increase internal stresses under certain conditions. Secondly, normal forces or axial forces. Forces of compression or tension operating along a structural member's length. Next, shear forces. It can lead to sliding failure between material layers because they act perpendicular to the member's axis. Bending moments. When members bend due to external loads, tensile stress develops on one side and compressive stress develops on the other. Last but not least, the factor of safety is defined as failure load or material strength divided by allowable or applied load. Besides, using a factor of safety is crucial due to aging and manufacturing tolerances can cause material properties to change. Secondly, errors may be introduced by idealization and modeling simplifications. Therefore, application to the selected structure. By comparing the maximum internal forces derived from equilibrium analysis with the permitted material strength, the predicted factor of safety for the examined structure was ascertained. The resulting FOS verifies that, under anticipated loading circumstances, the structure functions within safe mechanical bounds.
Hi, Assalamualaikum. My name is Dania Farsha binti Mustafa Kamal and my matrix number is B14241026, and I'll be presenting calculation and a little analysis on our report. So for calculation, we are firstly calculating the external load exerted on the structure using equation of equilibrium, summation of Fy equal to 0, and then we can assume the forces exerted on Fa and Fb is the same, and then that will be represented by F in the calculation. So negative 60 because the force is pointing downward, minus 20 Newton, minus 14.5188, which is the weight of a leg, times by 2, plus 2F, plus because the force is pointing upward equal to 0, and then negative 109.0376 plus 2F equal to 0, and then we'll get 2F equal to 109.0397 Newton, and then for 1F we'll get 54.51. And then we can continue to calculate the internal load on each of the system in the structure. We are still assuming that there's a 60 Newton load exerted on the structure, and we are also assuming that the load exerted by each of the legs is the same, and that is represented by L in the calculation. So using equation of equilibrium, summation of Fy equal to 0, and then negative 60 Newton minus 20 Newton plus 2L equal to 0, and then we'll get negative 80 Newton plus 2L equal to 0, so 2L will equal to 80 Newton, and each of the forces on the L is 40 Newton. Finally, we are calculating the forces exerted on the leg of the table. Because we are assuming that the forces experienced by the legs are the same, we are representing the calculations with one leg only. On the FBD, we can see that there's a 40 Newton load acting on the top of the leg, and that is from 60 Newton external load and 20 Newton weight of the top table divided by 2, and then there's a 54.51 Newton force acting upward of the leg, and that is the F that we calculated from the external load calculation earlier. So using equation of equilibrium, summation of Fy equal to 0, negative 40 Newton minus 14.0748 Newton plus 54.55 Newton equal to 0. So which means we have a balanced equation of equilibrium that proves that this structure is stable. So for a little analysis of the structure, there's two types of load exerted in between the structure of the model. First, we have dead loads, which happens around the connections of the structure, and then we have life load, which is a variable. And in our problem, the life load is the assumed 60 Newton force exerted on the top of the table. So the mechanical response on the structure is bending, and then the top of the table experience compression, and then the bottom of the top table experience compression. So from that bending response, we can draw a shear diagram and moment diagram. But in order to draw those diagrams, we have to calculate the critical moments of the graph. So we are using x equal to 0.3 and x equal to 0.45. At x equal to 0.3, the summation of Fy equal to 0, and then 40 minus 60 minus v equal to 0, and then we'll get v equal to negative 20, and then summation of moment equal to 0. We'll calculating negative 40 minus 0.3, which is the distance, plus m, and then the m will get 12, and then at x equal to 0.45, summation of Fy equal to 0, and then 40 minus 60 minus v equal to 0, and then we'll get the negative 20v, and then summation of moment, negative 40 times 0.45 plus 60 times 0.15 plus m equal to 0, and then the m will get a 9. So based on the value that we get from the critical point calculation earlier, we can see that a negative shear happen on the X that experience the point load, and on the moment diagram, the highest moment is also on the acts that experienced point load.
Next, me Nur Arfa Ali binti Helmi, metric number B1424100015, can talk about discussion. In this assignment, we focus on how a real-world physical structure can be simplified into an idealized model. This allows us to systematically evaluate its mechanical stability. First, we establish the main idea of the system and make clear assumption. Then we develop a complete free body diagram or FBD to visualize all external and internal force movement acting on the structure. Using this diagram, we apply the equation of equilibrium to calculate the specific force involved. This also allows us to determine the allowable force and predict the factor of safety used in the design. Overall, this approach ensures that our analysis is well supported by evidence and confirm the structural integrity and safety of the system we studied. Next and last is conclusion. In this assignment, we achieved a comprehensive evaluation of the structure's integrity through a detailed analysis of force and the factor of safety. By creating an organized technical report and idealized model, we successfully translated real-world observation into a rigorous engineering system. The development of precise free body diagram, along with the application of full equation of equilibrium, allowed us to accurately determine all external load, internal force, and moments. Using the systematic approach, we predict the allowable force and factor of safety, providing strong evidence-based support for the design and safety of the structure. Overall, our analysis confirmed that the structure meets the necessary mechanical requirement for its intense use while also demonstrating professional standard in technical report and structural modeling.